Hi there everyone, welcome to the first video in the playlist for OCR Further Maths A Level. We'll be covering some difficult questions in the past papers, and the first one is question 8 from the 2019 OCR A Level paper. It's on vectors, and vectors is one of the last topics you'll cover, and it's probably one of the harder topics, so I think this is a good kind of question to go through first. This is the second last question in the paper, so usually that means that it's going to be one of the more difficult ones, and it's worth 6 marks, so let's go straight into it and look at the question. So, it says the equation of a plane is 4x plus 2y plus z equals 7. Straight away, we know it's a plane, so we can just draw a diagram of a plane. It'll look something like this. And we've been given an equation in Cartesian form. And what we know about this is that the 4, 2, and 1, the coefficients of the x, y, and z variables, we know that that's basically the normal vector to the plane. So we have a normal vector to the plane n, and n is equal to 4, 2, 1. And this value is equal to the p-value, and that 7, that basically is specific to this plane. And then we have a point A, and that's coordinates 9, 6, 1, and the point B is a reflection of A in the plane. So we have to find the coordinates of the point B. So then we have been given the fact that A is equal to 9, 6, 1, and so there's a point A here, and basically we need to find the reflection of A in this plane. So somewhere over here there's a point B, and we need to find the coordinates of it. So what we do first is we realize that actually AB is actually parallel to n, which is the normal vector to the plane. So if we can find a point on the plane, so if we call this point M, like the midpoint between A and B, which is on the plane, then we can use the midpoint to find B. So what we do first is we write out the vector AB, and we say that when you're writing a vector equation in vector form, a equation of a line, you first need to find a position vector, and then you need to find the scalar multiple for the direction vector. So we know that A is a point on this line AB, so we can use the position vector 9, 6, 1 of A, and then we can also say that it's lambda, some scalar multiple of the direction vector, and the direction vector is equal to n because we're saying that AB is parallel to n. So then we can write 4, 2, 1. So this is the vector equation of a line for AB. And then what we can do is we can say that, if I rewrite this, we can say that AB is equal to 9 plus 4 lambda, 6 plus 2 lambda, and 1 plus lambda. And now we have an x, y, and z coordinate for any point on the line AB. And now if we use these x, y, and z coordinates and plug them into the original equation that we were given at the top over here, then we can use that to actually find the point where AB intersects with the plane. So if we do that, we can just get 4, 9 plus 4 lambda, plus 2, 6 plus 2 lambda, plus 1 plus lambda equals 7. And if we expand and rearrange, we get 36 plus 16 lambda, plus 12 plus 4 lambda, plus 1 plus lambda equals 7. That gives us 21 lambda equals to 7 minus 1 is 6, 6 minus 12 is minus 6, and that gives us minus 42. So we know lambda equals minus 2. That's a pretty nice number, so I think that's a good sign. And if I just move down, then what we can do is we can actually find the point M, because m is equal to 9 plus 4 times minus 2, which is 9 plus 4. And that is equal to just 1. And we have 6 plus 2 times minus 2, and that's equal to 2. And then we have 1 minus 2, which is minus 1. Again, nice numbers, so we're probably right. And if we go back to the initial diagram, we now have coordinates for A, and we have coordinates for M, so we can use that to find coordinates for B, because M is the midpoint of the line of the 2 points AB, and if you just use the regular formula that you've covered in A-level maths for the midpoint, maybe even GCSE even, then we know that the midpoint is equal to the sum of the two x coordinates of A and B divided by 2. So what we know is that 1 is equal to the x-coordinate of A, which is 9, plus some random x-coordinate of B, all over 2. So if we rearrange that, we know that x is equal to minus 7. Then we can do the same for the y-coordinate. 2 is equal to 6, because that's the x-coordinate for A, plus, y-coordinate for A, plus y, which is the y-coordinate for B, all over 2. And that will give us y is equal to 2 times 2 is 4, 4 minus 6 is minus 2. Let me just make the 7 a bit clearer. And then the last one is minus 1 is equal to the z-coordinate for A, which is 1, plus a random z-coordinate all over 2. And that gives us z is equal to minus 3. So to basically finish this off, we know that B, oh, what's happened now? So to finish this off, we know that B, the coordinates of B, is minus 7, minus 2, and minus 3. So the main things to kind of think about here are first drawing the diagram. That's the main thing you have to do in vectors, is draw diagrams. It's not like a topic like hyperbolics or some other thing where you can just kind of crunch the numbers. It's not trigonometry. You have to kind of problem solve these kind of questions. So draw a diagram. Understand that if you're given a plane, you should always use the normal vector to the plane. And if you're given coordinates, you should, for a position vector, you should try and write an equation of a line. And then from there, you can kind of work your way through it. So it's a good 6 marker. And I hope this was useful, and I'll see you in the next video. Thank you.